go to page 50 when we're done. All right, so the properties of exponents that we learned in algebra and that we reviewed yesterday can be used to manipulate or rearrange exponential functions into an equivalent form. So we talk a lot about equivalent forms, two equations that look different, but we graph the same thing, okay? So quick review of what we reviewed. We have the product property, so multiplying two terms with the same base, you add the exponents, we know that. And here's some examples, but remember, one of the reasons we went over this and it's being reviewed, even though I think you really know that one, is that we are going to do it backwards, okay? You need to understand how it works going backwards as well. Same thing with the power property. Power to a power, you multiply them. And that's a property we need to know, but we also need to know how to go the opposite way. So when I have 2 to the 3x power, I can rewrite it as 2 to the x power, then to the third power, or it actually could be 2 to the third to the x power. Like that works also. It doesn't matter which one's on the outside because you're going to multiply and you can multiply in any order. Okay. And then of course our negative exponent property. Okay. So talked about those a long time yesterday, so won't talk about them much more today. We're just going to use them. So it says the same exponent rules can be used when working with horizontal transformations of exponential functions. So we are going to determine the horizontal transformations of each of the following. Well, A is missing, so I don't know what happened to it, but here we go. I'll just write this in. F of x equals 4 to the x plus 2 power. Okay. So transformations. The transformations you've been talking about for years that for whatever reason, some of y'all just could not get right on that quiz. If you're trying to figure out if it affects x or y, with exponentials it's probably the easiest because if it affects x, it's up in the exponent. So that x plus 2 means that it's a translation. It's with the x, that means it's a horizontal. So I would put horizontal translation. But even though I know, would I be going to the left or to the right?
Is x a liar in this case?
X is always a liar, yes. So I would be going where?
To the left.
To the left. Okay. And we need to know that, right? We know that. We know it goes to the left because x is a liar, but we do not write left. Right, left. Didn't it? But we do not write down left. Instead, we say horizontal translation of what? -2. The left and right words, that is not how it is talked about for whatever reason. Okay. And I know that that's how you've always said it, but that's a little bit of a shift that we have to make. Shift, huh? A translation. All right. Questions? All righty. So then I have g of x here, and it's 2 to the 3x power. So again, that 3 is up with the x. So it is going to be a horizontal something. This time it's a horizontal what? Dilation. Good. It's a horizontal dilation by what?
1/3.
1/3. Very good, because x is a liar. Some of you trust x way too much, and that's why you missed all those transformations. X is a liar. All right. Now on C, when these types of things happens and we're dividing, I want you to think about, remember our rules are, we're usually talking about multiplying or adding, not dividing and subtracting. So I think it's a good idea, so that you don't try and do weird things, to rewrite this as 9 to the 1/2 x power. That's the same thing as x over 2. But it's when it's written like that, you see it as multiplication. Okay, does that make sense to you? And so that is multiplying again, so that is going to be a horizontal dilation of what? 2, because x is a liar. All right, we good with all that? All righty. Then this is subtraction. It's still with the x, so it's horizontal, but this is a translation. It's a horizontal translation of what? 1. And again, we need to know that that means we're going to the right one, but we don't talk about the right and the left. I have to use the signs of the number itself. Okay. Any questions? All right. So now we are going to re-examine the exponential function in example 1a, this one right here. Okay, and see if we can use our exponent properties to rearrange the function into an equivalent form. All right. So we have 4 to the x plus 2 power that is going to be equal to, so remember we're going to use the product property to go backwards. This would be the same as 4 to the x times 4 squared. I'm unadding, not necessarily subtracting, but just, splitting across from addition. But then 4 is a constant, so what's 4 squared?
16.
16. So this is 16 times 4 to the x. Okay. The base of the exponential a lot of times is in parentheses. I purposefully didn't write it in parentheses right here because you could see it that way as well. I think when you're writing it, it's probably best for you and me to put the parentheses there so it's very clear on what we're doing. But I do want you to know it could be written like that and it means the same thing. Can I legally multiply 16 times 4 right here? No. Okay, because 4 has that x on it, right? If 4 didn't have an x on it, then I could, but there are different things there, right? So that means that f of x equals 4 to the x plus 2 is equivalent to f of x equals 16 times 4 to the x. Right. They look completely different, but if you graph them both, you get the same thing. Okay, everybody good? Okay. So then it goes on to say, when we rewrite the exponential function this way, there is no longer a horizontal translation, but now we have a vertical dilation. So changing it from translations to dilations. So the important idea that we get out of this is that every horizontal translation of an exponential function, so not of every function, but for exponential, is equivalent to a vertical dilation of the exponential function. Okay, every single one of them. Again, not for every single function ever, but for every exponential, just by the nature of their properties. So if we look at what we have here, we have a function that is 2 to the x, and you have this on your paper as well, except yours aren't colored, so they just look like, can't really tell which is which on there. But I have this 2 to the x, and that's the blue one. If I have 2 to the x plus 3 right here, that means I would shift to the left 3. So my blue one gets shifted left to the 3, and I get the red one, right? Visually, that makes sense. If I change this one, which let's go ahead and do, this is a right here, so let's just do that. It's the same thing here. So if I change this, this is equal to 2 to the x times 2 to the third, right? Because I'm using the product property backwards. 2 to the third is what? 8. So this is 8 times 2 to the x power. So see, I just adjusted it like we just did up there. And so it turns this one into this right here, where this means that I have a vertical dilation of 8, or a vertical stretch. So think about taking this, and if it's like a piece of string or something, and you can hold on to the end of the blue one and you just stretch it up, we could stretch it up and it would lay right on top of the red one. Okay, so whether I move it over or whether I stretch it up, everything's going to lay in the exact same place, gives you the exact same function. Okay, everybody good so far? All right. Well, we did this one without actually reading the directions, so let's actually read the directions. It says each of the following exponential functions has a horizontal translation, which is actually a falsehood. That's why this has a little star on it, but that's okay. For each, we're going to write an equivalent representation. That's the important part, an equivalent representation that has a vertical dilation and no horizontal translation, right? So that means I'm going to undo that product property. So if I have 3 to the x minus 2, that's going to give me 3 to the x times 3 to the negative 2 power. What is 3 to the negative 2 power?
1 over 3 squared.
1 over 3 squared, and what's 1 over 3 squared?
1 over 9.
1 over 9, very good. So that negative makes it 1 over 3 squared, and then we square it. So we'll get g of x is equal to 1/9 times 3 to the x power. Okay. Everybody good with that? Okay, it's not that complicated. You just got to know, legally what you're allowed to do and not allowed to do here. Okay, so then here, this would give me 4 times 3 to the x times 3 squared. Can I multiply the 4 times the 3 right now?
No.
No. But after I square this 3 and it becomes 9, now can I multiply 9 times 4? Yeah, because it's a plain old number. So that means that k of x is going to equal 9 times 4 is 36 times 3 to the x power. Okay. Any questions on that? Okay, so D has a little asterisk on it because we're going the other way. Instead of taking a translation and making it into a dilation, we have a dilation, we're making it into a translation. But it's 2 to the x over 32. First of all, can I reduce the 2 and the 32? No, because there's that exponent on it, right? If there was, so I had this question earlier, so let's just talk about this before we actually get over there, and then I'll erase this part here. So we have 2 to the x over 32. Cannot reduce that 32. Cannot reduce the 2 and the 32. If I had 2 times 2 to the x over 32, then I could reduce these because these are just plain old numbers. You see the difference there? So it's not knocking that stuff out, just to make sure we understand that part there. Okay. All right. So, but what we're going to do here is just like right, where was it? Right here, instead of looking at that as division, let's look at it as multiplication and rewrite this as 1 over 32 times 2 to the x power. Okay, isn't that the same thing? Okay, but now I see it as a vertical dilation, which would be a compression, not a stretch, but we still talk about it as a dilation. Now, in order for me to be able to combine these two, basically going this direction, having this to go up to here, I need the bases to be the same. This base is already 2. So I need to rewrite this as 1 over 2 to some exponent. 32 is 2 to what power? The 5th power, okay? So I get 1 over 2 to the 5th times 2 to the x power. Everybody good so far? But that's 1/2 and 2. So what can I do with that 1 over 2 to the 5th to make the base 2? Negative exponent, right? I'm not making the 2 negative, right? I make the exponent negative. So this is the same as 2 to the negative 5th times 2 to the x power. Okay, because that negative just gives me the reciprocal there. Now that I have that, now I can use my product property and get h of x equals 2 to the what power? X minus 5, yes. What questions do you have? We're good? Okay. All right, flip it over. So another way we can manipulate these is using the power property to show that every horizontal dilation of an exponential function is equivalent to changing the base of the exponential function. So we're going to start off with the same 2 to the x power, right? Then we have, so that my blue one is 2 to the x in all 3 of these. Right here in this g of x, that's 2 to the 3x power. Remember, x is a liar, so when I multiply by this 3 right here, that's really taking all of those x values, multiplying them by 1/3. So that's what makes it a horizontal compression. It gets squished in. That's why the blue looks like it's been squished in and made into the red. Okay. If I were to take this and use my product property, so I've got our power property. I've got 2 to the 3x power. I can rewrite that as 2 to the 3rd to the x power. Then 2 to the 3rd is 8. And that's where I come up with this one. The larger the base is on an exponential, the faster it grows. Instead of something being doubled every time, it's being multiplied by 8 every time. So instead of coming over here and growing slower like the blue one, it grows faster like the red one, but it would be the same as the horizontal dilation. Okay. Again, just by the nature of exponentials, they end up being the same thing. Everybody good? Okay. I went into example 3 and I changed, I tried to fix the instructions and I think I made it worse. It says each of the following exponential functions has a horizontal dilation. And I guess it does. I don't know why I thought that was bad. For each, write an equivalent representation that has a vertical dilation and no horizontal dilation. maybe I'm just crazy here. I thought, so that's the only false part is this one has a little star by it because really on this one we're going the opposite direction. Whatever. We're going to make it an equivalent representation. When it comes right down to it, most of these you have are going to be multiple choice, and so it's just going to tell you to put an equivalent form. It's not going to tell you to change it one way or the other. You're going to have to understand that that's how it works. Boys, y'all with me? Xavier, you with me? Xavier. Xavier. Okay. All right. So 9 to the x power. I can change 9 into 3 squared to the x power. Okay. Then I'm going to show you what I did last period, because this is what I mean by sometimes you go in circles. And I think I was still distracted by the instructions and somebody asked me a question. So I was like, okay, so we have 3 squared to the x power. So we can make that f of x equals 9 to the x power. And then I was like, well, I'm not wrong, but did I even do anything? No, I just went back. This is where you start going in circles. Like I could do that all day long. Like I'm not wrong, but I didn't do anything. So clearly not what I intended to do. But when I'm here, what I really was trying to do was make it look different. And this can become a 3 to the 2x power. Okay. We go with that? So didn't have a horizontal dilation, now we do. So it's kind of the opposite of what the instructions say. All right, on this one, again, I would rewrite this as 16 to the 1/2 x power. That's an exponent, but I can't write that much smaller on here. So that means, oh, and I didn't name this one. We'll name this guy G. This would be G of x. So then I would have 16 to the 1/2 power to the x power. What is 16 to the 1/2 power? 4, because that is the square root. So this would be 4 to the x power. So right now, what we did is we took this that had a horizontal dilation, and we ended up with this that gave us a different base, and which is what the instructions said. But we're going to do one more thing, because I can write it even differently, and I just want you to see that there's a lot of things you could do. So if it's multiple choice, you might have to go a few different ways here. But I can take that 4 to the x, and I can change that into 2 squared to the x power. So I can make that g of x equals 2 to the 2x power. And so then all 3 of those things would graph the exact same function. They're just different forms based on your exponent rules. Okay. What questions do you have? Okay. So then let's look at this one here. I got 4 times 3 to the 2x. Can I multiply the 4 times the 3?
No.
No. Does that exponent of 2x have anything to do with my 4? No. Okay, so don't go making stuff up. And we'll call this guy, what did I call him? H. This will be h of x. So this can give me 4 times, and I can make that 3 squared to the x power, right?
Yes.
And then this is going to, so then h of x is going to equal 4 times 9 to the x power. Can't multiply the 4 times the 9 now either. So the 4 just hangs out there and it doesn't change. That number changed when it was on the front, because we were changing from a translation. So just make sure you do it correctly when you can multiply things together and when you can't, because I think you really do know those rules, but sometimes we just do weird things. Okay? Questions? We good? All right. So let's look at example 4. Now, before I even look at my answer choices, notice it just says which one is an equivalent representation, right? An equivalent form. So it's not telling me directly to go in one way or the other. I obviously have answer choices that could lead me down one road, but we're just going to pretend like they're not there right now and do 2 different things. Yes, sir. Go ahead.
Did you say no horizontal translation?
No, it should have said, it did say that. Okay, right now it has a horizontal dilation. So we wanted a vertical, see, it shouldn't say vertical dilation. That's why I said I changed the words and it's still wrong, because we don't have a vertical dilation. The instructions are just all wrong. So we're just trying to do, let's just Because I looked at last year's and I just scribbled them out because they were wrong. And I thought by changing a couple words, I made it worse. So it's just even more wrong. We were just making equivalent representations. We went from horizontal dilation to changing the base is what really that should have said. Yeah. But no translation anywhere on these in particular. On the front we did. Yeah, I know. Because it literally just doesn't even make sense. So that makes it even worse. Okay, so equivalent form. So again, we're just going to ignore our answer choices for just a second, and we're going to look at two different ways to approach this. So I could do 9 squared to the x power. That would give me 81 to the x power. Or I could do 3 squared to the 2x power. Right, because 9 could be 3 squared. And then this could be 3 to the 4x power. So those are two very different things. I do have a base over here that is 3, and I have a base that is 81. But there's only one that matches what I believe to be the correct things. Sometimes I think it's better for y'all just to do it, then check your answer choices, than to try and find an answer choice that matches, because like what's in your head, because that's where we do weird things sometimes. But that does make our answer right here D. There's no way to get an 18 as a base like that. Okay. What questions do you have? All right. So then on this one here, again, we're looking for equivalent form. I got a couple things I can do here. I could do 9 times 2 squared to the x power, which could give me 9 times 2 to the 2x. Now, if I'd have looked at my answer choices before I started, I know actually that going with 2 with a base is not my goal. But again, I just want you to see that that could be an answer choice possibility. My base is supposed to be 16. So I got to change that 4 into 16 to something. So 4 itself is 16 to what power? To the 1/2, because it's the square root. So 16 to the 1/2, all I did was change that 4 to 16 to the 1/2 power. So then that gives me 9 times 16 to the 1/2 x, or 1/2 times x is x over 2, which would be C. Okay. Any questions at all? We good? Yes, sir.
I'm just a bit confused about how we got it to 16 to the 1/2.
Well, because I know that I need my base to be 16. So I'm taking whatever, like right now, this is 9 times 4 to the x. So I just need this value to be 4. And if I need this base to be 16, I had to figure out what exponent is going to make this whole thing inside of here become 4. And it's 1/2 because it's a square root. Okay. Good question. Anything else? All righty.